The historical record contains a narrower but consequential documentation problem regarding the events of August 9, 1945. On that date, a Boeing B-29 Superfortress named Bockscar executed the mission to drop the Fat Man atomic weapon over Nagasaki. After the war, some official reports mistakenly credited the observation aircraft, the Great Artiste, with the strike. That error did not erase Bockscar from existence, but it did create a documented discrepancy that had to be resolved when the aircraft was prepared for museum preservation. Resolving the discrepancy required an institutional review, not a field search. Some records had assigned the Nagasaki strike to the wrong aircraft. The objective of the ensuing institutional review was to reconcile the aircraft's physical identity with the documented mission history. Before permanent institutional preservation could proceed, curators and military custodians had to place the stored machine into its correct historical context. The physical reality of the evidence challenged the mistaken written reports. The true strike aircraft was a Boeing B-29 Superfortress named Bockscar. A primary anchor for this identification was the aircraft number, not the later confusion in the paperwork. The bomber was Boeing B-29 number 4-2 7297. That sequence tied the physical airframe to the documented historic event. The military documentation system relied on typewritten mission reports, unit summaries, and maintenance records. When some of those records misaligned with the physical aircraft, evidence discipline meant returning to the aircraft number, the mission history, and the airframe itself. What was verified was the physical existence of the aircraft bearing that number. What required correction was the mistaken attribution that appeared in some post-war reporting. Despite this physical proof, the reporting error still mattered because it had to be resolved before the aircraft could be preserved correctly. After the discrepancy came to light during preparations for eventual museum display, Bockscar was retired in September 1946 to the Desert Storage Facility at Davis-Monthan Field near Tucson, Arizona. There, the aircraft remained outdoors as part of a controlled military storage system rather than as an unknown piece of wreckage. For roughly 15 years, the machine remained in desert storage. During those years, the dry Arizona storage field became the fixed point against which the mistaken reports had to be tested. Curators had to compare the reports crediting the Great Artiste with the aircraft actually used by Sweeney's crew on August 9, 1945. Then tie aircraft number 4-2 7297 to Bockscar and to the Nagasaki mission. The stakes were procedural and historical. Until the discrepancy was resolved, the museum could not present Bockscar as the definitive machine of the Nagasaki mission. How does the definitive machine of the atomic age become entangled in a paperwork error and then return from the desert as a verified artifact? The fundamental design boundary for the standard Boeing B-29 was its maximum structural limit of 133,500 pounds. Operating anywhere near this maximum weight, restricted altitude, slowed climbing rates, and vastly increased fuel consumption. The specific mission profile for this aircraft required the transport of a single, highly concentrated 10,000-pound payload. Accommodating this massive ordnance within the forward bomb bay mandated a complete reconfiguration of the standard aerodynamic and operational envelope. To meet this strict weight and performance constraint, the aircraft was heavily modified under the highly classified Silverplate program. The engineering logic of the Silverplate program was dictated by drag reduction, weight elimination, and the need to create a wider escape margin after release. The engineering teams executing these modifications faced a harsh trade-off. To improve range, speed, climb performance, and post-release separation, they had to systematically remove standard defensive equipment. The team stripped away heavy interior armor plating. They also removed the complex remote-controlled gun turrets and their associated ammunition feed systems, retaining only the rear gunner's armament. This institutional decision prioritized mission-specific performance over conventional combat survivability. Compensating for the extreme operational demands required maximizing propulsion efficiency. The aircraft was equipped with specialized Wright-IER-3 350-41 radial engines. Each of the 4 power plants was rated to produce 2,200 horsepower. Operating at heavy gross weights in thin, high-altitude air placed major thermal and mechanical stress on the engines. To improve reliability and performance, the updated engines incorporated better cooling, fuel injection, and improved fuel and manifold systems. These changes gave the Silverplate aircraft a stronger performance margin during the long transit and escape profiles, without pretending that the engines were free from mechanical risk. The actual release of the 10,000-pound payload created an immediate and severe escape time boundary. Standard heavy bomber hydraulic bomb bay doors actuated more slowly, prolonging the drag penalty during the critical moments around weapon release. To overcome this limitation, the engineering team installed a specialized pneumatic door mechanism. Replacing hydraulic fluid actuators with high-pressure compressed air allowed the massive bomb bay doors to cycle faster. This shorter transition reduced drag exposure and helped the aircraft enter the steep, high-acceleration diving turn required to increase separation from the blast. Returning a heavily modified aircraft to a forward operating base introduced another severe operational constraint. The bomber operated from island airstrips with a strict stopping distance limit. Landing a large aircraft, even when depleted of its primary payload and fuel, posed a continuous overrun hazard on short runways. To resolve this geometric limit, the aircraft was fitted with Curtiss reversible pitch propellers. Upon touchdown, the flight crew could mechanically alter the blade angle to direct thrust forward instead of backward. This system utilized aerodynamic braking to forcefully decelerate the aircraft, absorbing massive amounts of kinetic energy, without relying exclusively on the mechanical friction brakes of the landing gear. Every modification applied under the Silverplate program served a singular, highly restricted operational objective. The removal of armor, the rapid pneumatic doors, the enhanced engine cooling, and the specialized braking systems transformed the aircraft from a standard fleet bomber into a precision delivery platform. It was stripped of everything unnecessary and reinforced only where the specific physics of its solitary mission demanded it. The aircraft possessed no excess capacity. Its entire structural integrity was balanced against the exact requirements of dropping one weapon and escaping the immediate airspace. The airframe was perfectly modified to survive the physics of its mission, but how did an administrative flaw erase it from the official record? The tracking gap traced back to a highly specific, last-minute operational decision on the flight line. The primary flight crew assigned to the August mission traditionally operated the Great Artiste. Under standard procedures, crew and aircraft assignments moved in tandem through the logistics network. However, strict mission constraints dictated a complex technical setup. The Great Artiste was already rigidly configured with highly specialized heavy blast measurement instrumentation for its designated role as the observation ship. Reconfiguring this delicate equipment on the tarmac to convert it back into a weapon carrier would violate the strict operational time window. To resolve this flight line constraint, the operational commanders executed an immediate aircraft swap. The flight crew was physically transferred to Bockscar, an identically modified B-29. While the crew and weapon moved to Bockscar, some early summaries lagged behind the physical exchange and followed the crew's earlier association with the Great Artiste. By the time preservation planning began, museum personnel had to correct that attribution before presenting the aircraft with confidence. The airframe was then handled as a stored aircraft awaiting its final institutional role. The stored airframe's identity remained the precise institutional problem. The machine was Bockscar, number 4-27297, while some written reports still credited the Great Artiste. Overriding the compounded administrative problem required museum personnel to separate the mistaken attribution from the aircraft tied to the Nagasaki mission using aircraft number 4-27297 as the controlling identifier. Placed against the Silverplate record and the Nagasaki mission history, that identifier confirmed that the airframe in the desert storage field was Bockscar and gave the aircraft its correct institutional status. The archival identity was clarified, but in what physical condition did the actual airframe survive after more than a decade in storage? After roughly 15 years outdoors in desert storage, the targeted airframe raised structural questions about solar exposure, seasonal thermal cycling, and long inactivity. Standard aviation practice treats long-dormant aircraft with caution because metal structures, seals, fluids, engines, cables, and control systems can age at very different rates. The assessment team had to determine whether the aircraft could safely make one final ferry flight, not whether it could return to wartime service. The military had not chosen Davis-Monthan randomly. Its high-altitude desert setting, roughly 2,550 feet above sea level, low relative humidity, and hard alkaline soil slowed the rapid oxidation that destroys dormant aluminum structures in humid or coastal storage environments. But passive preservation protected metal better than age-sensitive systems. Lubricants, seals, hoses, gaskets, wiring, and hydraulic components could not be assumed safe simply because the aluminum structure had survived. Heat and time still forced careful inspection of the soft materials required for mechanical operation. The recovery team faced a complex structural judgment. They had to evaluate the boundary between an airframe preserved well enough by desert storage and mechanical systems aged by years of inactivity. Their survey narrowed to flight-critical structure and the systems required for a controlled ferry flight. Any serious structural weakness would have ended the plan to move the artifact intact. The physical survey confirmed the bomber's deep structural integrity. The heavy aluminum frames were sound, and the flight surfaces remained true. The passive stability of the alkaline soil prevented the landing gear from sinking, keeping the aircraft level and reducing static stress on the airframe over the 15-year duration. That structural finding forced the next decision. The aircraft was physically sound, but its size made overland extraction destructive. Cutting wing spars and dividing the fuselage would leave permanent forensic scars. The team therefore faced a stark choice between a complex ground move and a high-risk ferry flight out of the desert storage facility. After weighing the preserved structure against the risks of disassembly, the team accepted the operational hazard. Bockscar would fly out under its own power. This decision immediately shifted the recovery project from a slow logistical trucking operation to a highly constrained active aviation event. Executing the extraction flight required a narrow maintenance standard, not a complete combat restoration. Crews concentrated on the systems needed for controlled departure, cruise and landing, engines, fuel safety, ignition, hydraulics, braking, propeller pitch, and control response. The flight crew would keep the aircraft inside a heavily restricted envelope. The recovery team accepted that they were operating a machine carrying the mechanical uncertainty of a decade and a half in storage. Once the 4 engines were coaxed into sustained operation, the crew taxied the heavy bomber onto the desert runway. Every essential system, from the brakes to the propeller pitch controls, had to function adequately just long enough to reach the final destination. On September 26, 1961, the engineering trade-off proved successful. The crew accelerated the aircraft down the runway, lifted it out of the dry Arizona air, and flew it to Wright-Patterson Air Force Base in Ohio. The extraction flight bypassed destructive cutting procedures and preserved the unbroken physical structure of the airframe. The bomber landed safely at its final institutional destination. The extraction flight successfully delivered the machine intact, but what curatorial steps were required to lock its historical accuracy? What investigators could verify upon the safe arrival of the aircraft was that the primary physical structure remained unbroken. What remained procedurally unacceptable was the exterior visual configuration of the airframe, and this discrepancy mattered because it actively perpetuated the original post-war documentation failure. The bomber was now safely housed inside a controlled institutional hangar, but its aluminum skin still displayed the false identity created by the flawed military archives. The aircraft entered the museum restoration facility carrying a compounded historical error directly on its forward fuselage. During its time in the desert storage lot, maintenance personnel had followed incorrect logistical directives and painted the name of the observation ship, the Great Artiste, onto the aircraft. The institutional decision facing the museum directorate was uncompromising. The conservation team had to permanently erase these erroneous post-war markings to force the exterior presentation of the aircraft to match the absolute physical proof of its internal serial plate. The artifact could not be placed on public display while actively contradicting its own historical reality. This operational mandate triggered a rigid process of heritage configuration reversion. In a forensic museum environment, restoration is an act of physical verification rather than simple cosmetic improvement. The engineering team did not simply apply a fresh coat of paint over the boneyard errors. They had to systematically strip away every layer of unverified and historically inaccurate material to recover the authentic baseline of the machine. Conservation specialists utilized controlled chemical solvents and meticulous mechanical polishing to safely remove the false paint scheme. The specific constraint during this phase was to dissolve the heavy postwar paint without scoring, scratching, or chemically weakening the original thin aluminum skin beneath it. The procedural objective was to return the massive structure down to its bare metal state, completely neutralizing the archival mistake that had caused its initial abandonment. Once the exterior surface was stabilized, the curators executed a controlled reconfiguration of the airframe for display. In a museum environment, restoration is an act of physical verification rather than simple cosmetic improvement. The team did not need to reject all post-war military records. Instead, they had to weigh the mistaken reports against the aircraft number, the documented mission history, and available photographic evidence. They cross-referenced those sources with the physical identity of aircraft number 4-27297. Following this evidence chain, the restoration technicians aligned the aircraft's exterior identity with Bockscar rather than the Great Artiste. The team had to distinguish the aircraft's mission day appearance from later commemorative markings. Official museum captions show that Bockscar carried no nose art in a crew photograph taken 2 days after the Nagasaki mission, and that the Bockscar nose art was added after the raid. By separating the verified aircraft identity from later display markings, the museum prevented the exterior presentation from repeating the original reporting mistake. The physical machine now served as the strongest proof against the bureaucratic tracking error. The aircraft was finally insulated from further logistical misidentification. It successfully transitioned from a stored military airframe into a permanently stabilized institutional asset. The overarching recovery operation did not require heavy lifting equipment in an ocean trench or deep excavation through a shifting glacier. It relied on evidence discipline, challenging mistaken paperwork with the aircraft number, the mission record, and the hardware itself. To ensure long-term stabilization, the museum placed the aircraft in a protected indoor display environment, eliminating the external hazards of desert storage. Today, the Boeing B-29 Superfortress, known as Bockscar, is preserved and displayed under its correct identity, securing the physical truth of the Nagasaki mission without overstating every marking as Mission Day original.